Algebra I 12.4a, what is a quadratic function? Well, a quadratic function is a function that can be represented by y equals ax² plus bx plus c, or you might see it written as the function of x equals ax² plus bx plus c, as long as that a isn't a 0. So here's what I want you to check out. You might want to write this down. X is the domain, the input, the x value, that x coordinate. Y is the range, the output, the y value, the y coordinate, or the function of x. So we can make a function table like we did before with linear equations and linear functions, and we can say that that is the y, the output, see? And this is solved to find a range of values for x. So x could be a whole set of answers. A quadratic equation is solved for one value of x, and it has an equals 0 at the end. This finds a range of values that x can fall into, okay? When we graph a quadratic function, it makes a parabola. And you say ra with an accent, okay? Parabola, when the domain x is a set of real numbers. And parabolas are U-shaped curves, and they're facing up or down. Their width can vary, as well as how steep they are. They might be really open like this and wide, or they might be narrow. They might have a real steep slope like this one, or less of a slope like this one. And a line is graphed as a linear function by finding the x and y values that fit a linear equation. And we've done this before, and we graph a line. And when it heads up to the right, it's a positive slope, right? And when it heads down, it's a negative slope. Well, we can graph a quadratic function as a parabola that U-shape by finding x and y values that fit a quadratic equation. We're going to talk more about quadratic equations in Chapter 13, okay? Right now we're talking about functions and all the values that x can represent, the range of values. So parabolas have one vertex, just like on an angle. And the y-axis is the line of symmetry when the vertex is at the origin 0, 0. So take a look at this. The vertex is sitting at the origin 0, 0. That means that this y-axis is the axis of symmetry. It's cutting this parabola right in half. See? So if we have this heart, and this is our axis of symmetry, it's cutting this heart directly in half, see? And we can find the domain, that x, or input. And we can find the range and the function of x, the output. See? We can make a table. And actually, if you look at this, there's a negative value that matches a positive value. If we're at negative 3 and 2, the exact opposite is going to be at positive 3 and 2. See that? We'll talk about that in the next video. So color coding this, if A is red and the B is blue, and we're setting our x to be a green, when the value for A, it's the coefficient for x². When that's a positive number, the parabola opens on top. When the value for this A is a negative number, the parabola opens downward. See? So what happens is when A is larger than 0, so here's 0, we got 1, 2, 3, 4, 5, 6, it's larger than 0, it opens up. And when A is smaller, less than 0, it opens down. See? Negative 1, negative 2, negative 3. See? Isn't that cool how that happens? So we've got this standard form of a quadratic function, and if you see it written like this, look at the x² is in the back. This is a quadratic function because it can be rearranged and rewritten in standard form. This is just not in exponential order, is it? Do you remember exponential order? That's when you put the exponents in order from greatest to least. You can also see it in a polynomial where it's from least to greatest. So this x² is bigger than this x, so it should be in front to be in this standard form. And this 2 should be in the back. That's a positive 2, isn't it? So we can put this positive 7 up here and this positive 2 back there and put it into standard form. Okay? So there's parabolas everywhere around us in the world. When you look at car headlights, this is the car, and its headlights are making two parabolas. They're overlapping each other. See that? The cables of a suspension bridge can make a parabola. Satellite dishes form parabolas. Bird baths, hair bands, plastic hair bands that you hold your hair back with. And even the bowls at a skate park can make a parabola. See that? So they're everywhere. Our next video is going to be 12.4b. We're going to actually talk about how to graph these quadratic functions. And of course, always in this Algebra I playlist, if you want to go to one of the previous videos because you're lost, you missed something, you skipped something, go to this description of this video and watch the videos that you may have missed to fill in your education, okay? If you don't understand something, it's because you got ahead of yourself, all right? And you need to go back and find out what you missed, all right? I'll see you next video. Bye.